So this lesson is volume of prisms. And volume of prisms work the same way for almost every prism. There might be an exception here or there, but for the most case, the volume is the area of the base times the height. We're going to look at three prisms in this lesson. We're going to look at rectangular prisms because it has a base that is a rectangle, or the bottom or the top. It has the volume of a triangular prism, so the base is a triangle. And we can see the different orientations there. And the volume of a cylinder, which I guess you could kind of argue could be a circular prism because the base of this is a circle and then it extends up. So the volume of any prism, even a cube, which I didn't show in the last lesson, but it is the area of the base. So for a cube, we had the length times the width times the height. I didn't show that, but I should have. And the length times the width is the area of the base, the square, times the height. So we still have the area of the base times the height. And this is for the volume of any prism. So we're just going to look at these three. So, example, find the volume of the following. So here, I have a rectangular prism, and the volume is equal to the area of the base, so base area times the height. So the base area is this rectangle along the bottom, which is 6 times 2. This is the easiest type of prism. 6 times 2, and then times the height, which is 5. So the volume is 12. 6 times 2 is 12. Times 5, of course, is 60. And the units are, in this case, centimeters. And because it's volume, we're going to put that little 3 cubed. So 60 centimeters cubed is the volume. I'm going to put a little box around my answer because then it's easy to see. So that is for a rectangular prism. Okay, so this was a rectangular prism. The next example is a triangular prism. And what is the base shape on this one? It's a triangle. And how do we find the area of a triangle? Well, the area of a triangle, if you recall, is base times height divided by 2. That is the area of a triangle. And we're going to have to know that because for this triangular prism, that's what the base is. It's a triangle. And in order to find the area of that for the volume, remember I need base area first. Then I multiply that by the height. So in this case, the base area, if I can look at this triangle, I have dimensions 3, which could be, I guess, the height of the triangle, 6, which is the base of the triangle, and 7 we're going to use for the other part, but not, actually 7 we're not going to use at all. That's not needed information, but just be aware that sometimes they may give you information that you may not need. So 6 and 3 are the values we're going to be using. And that's the base area. So I have 6 times 3 divided by 2. That is the area of the triangle. The base area, the area of the triangle, times the height, which is 15. So the volume in this case, 6 times 3 is 18, divided by 2 is 9, times 15. Sometimes the numbers get quite large. So 9 times 15 is 135. So my volume is 135, and the units in this case are inches cubed. Okay, so it's a triangular prism. We needed the area of a triangle for the base, and then we just multiplied the area of the triangle by the height. Okay, the next example here is the cylinder. I'm just going to move this down so I have enough space. So the area or the volume of a cylinder, same basic way that we do it. However, if you noticed up top, I did show a formula. It was the volume of a cylinder was pi r squared h, and I'm going to explain how that works. So the volume is pi times r squared, and then times h. Can you see how this relates to the area of the base times the height? Because in this case, what is the area? What is the base shape? It's a circle. How do we find the area of a circle? The area of a circle is pi r squared. Pi r squared is the area of a circle. So, in this case, what's the radius? I'm given the diameter, and sometimes they will do this. You need the radius, you're given the diameter, you have to find the radius. And of course we know that the radius is half of the diameter, which should be 4. Because radius is going to be half the distance, right? The diameter goes all the way across, radius is half the distance. So the radius is 4 feet. So for the volume of this object, the cylinder, I have pi times radius squared, bed mass, remember to do your exponents first, and then times the height, which is 20. So in this course, I prefer using the pi button on the calculator. It's far more accurate. But before we do the pi times 4 squared, we're going to do the 4 squared first. Always do your exponents first. So I did my exponents, 4 squared. Now I multiply that by pi. Then I take that answer and I can keep all of this on my calculator times by 20, because then you get the most accurate answer. And I get 1005.3. And the units on this are feet cubed. Okay, so the area of the base, because it was a circle, is pi r squared times the height. We use our pi button on our calculator, but we also must do the r squared first. Most calculators are fine not doing it, but I still like to keep a habit of using the order of operations, so keep that in mind. Okay, so that is the volume of a cylinder. The last example I'm going to show is more complex example, where there's a piece missing. There's actually a cylindrical hole right through the center of this larger cylinder. Okay, so what we're going to have to do, and we're supposed to find the volume of this object, what we're going to have to do is find the volume of the entire shape, of the entire big cylinder, and then subtract off that little cylinder that's been cut from the inside. This could be a pipe, a tube of some kind, an engineering type question, a very simple one. So, of the big cylinder, okay, I'll just say big cylinder, and we'll find the volume of this one first. Then we'll subtract off the smaller cylinder. So for the big cylinder, it's still pi r squared h. I'm using a little h this time. Usually for cylinders, they use a little h. Most of the time, use a little h anyways, but it's okay. Pi r squared h. So for the big cylinder, what's my radius of the big cylinder? Okay, so that's that red one here. The black one shows the radius of the small cylinder. So my big cylinder, and they both have the same height, which makes it a little bit easy. So the radius, this is given the actual radius this time. I don't have to divide it by 2. It's not giving me the diameter. It's giving me the radius. So pi 8 squared times the height, which is 19. So again, I'm going to use my calculator. 8 squared is 64 times pi times 19. You don't have to hit equals every time, but I like to do that so I know what the actual running total is. So I get 3,820. We'll round to 2 decimal places, 0.18. 3,820.18. And this is in inches cubed. Okay? Now we're going to look at the small cylinder, the one on the inside, the one that's been cut out. So the same volume formula, pi r squared h. The volume is equal to pi. The radius of the smaller cylinder is 4. We don't have to cut it in half again. It's given us the actual radius. So pi 4 squared times 19. So pi squared forward times 19. So the volume of this object, again, do order of operations. So I do 4 squared first, which I know is 16, times pi, times, and see, I didn't have to hit equals. You don't have to hit equals. Is equal to 955.04. We're rounding to 2 decimal places. 955.04, and that is, of course, oh no, inches. Whoops, not feet. In inches cubed. So for the final, the complex object, the complex cylinder with the hole, we're going to have to subtract those two. So finally, we subtract. We take 3,820.18, and we subtract off that center volume, which is 955.04, to get a very accurate answer. So the volume of this shape will be, let's see here, so 3,820.18 minus 955.04. Just double checking to make sure my numbers are all correct, is equal to 2865.14. And that is inches cubed. So that is the final answer of this object with that middle piece missing. So a bit of a longer lesson, but a lot to kind of go over, a lot to cover. Just make sure maybe you can rewatch it again if you get stuck. There's only 3 objects that we have to look at the volume for this lesson. Thank you.